Hello, this is Susan Poss. I'm an instructor at Spartanburg Community College, and today I would like to talk to you about subtracting with algebraic fractions, rational expressions. And I'm going to do an easy one first where the denominators match. You can see in this diagram here, we're looking at two fractions. We're looking at subtraction. We have denominators that match. So the process is to keep the common denominator and then subtract the two numerators. So let's scroll down and take a look at an example. So you'll notice the operation is subtraction, and you also notice that the denominator is common or matching. So we don't have to be concerned about getting a lowest common denominator. We're just going to go ahead and draw one fraction bar, write down that common denominator one time, and then 2x minus 5y is the first numerator, and then this is where you have to be careful with subtraction. So we're subtracting this entire numerator, 3x minus 7y. So I'm going to go ahead and put that second numerator in parentheses so that you can recognize that I'm going to need another step here to make some sign changes. The positive 3x becomes negative 3x, and the negative 7y becomes positive 7y, and notice that the parentheses are now dropped away. And let me combine some like terms. So here's a 2x and a negative 3x to get a negative 1x. And here's a negative 5y and a positive 7y for a positive 2y. So again, as long as the denominators match, you can go ahead and combine the two numerators. But I'm going to put a red star right here because this is the place where it's very easy to make a sign error. So notice that these both reversed over here from what they were to the opposite sign. Okay, so that's our first example. Here's another one that has matching denominators. So again, relatively easy. We're just going to draw one long fraction bar. Write down that one common denominator, and then pick up the numerator. So there's the x squared, here's the subtraction, and again I'm going to use the parentheses around that second numerator so that we don't make any sign errors. So I'm going to make those sign changes. This positive 2x becomes a negative 2x, and this positive 8 becomes a negative 8. So I'm finished with the subtracting part. Now I need to see if I can possibly reduce this thing. So let me do a little factoring here. Remember, the rules for reducing is you factor everything, numerator and denominator, and see if there are any common factors that can be canceled out. So let me think of two numbers that will multiply to give me a negative 8 and also combine to give me a negative 2, and I think that will do it. If you check the outer product, there's a positive 2x, and the inner product is a negative 4x, and those combine to give me this negative 2x. So now I'm doing the reducing step, and you can see that these factors, remember you can only cancel factors, things that are multiplied together. I cancel those out and then give you the reduced form of the answer, which is x minus 4 over x plus 2. And a reminder, you need to stop there. Don't be tempted to cancel out these x's or this 2 and the 4 because they are not connected by multiplication. They are not factors. They're connected by addition and subtraction. All right, let's see. I think I wanted to show you, here's the common error that I was talking about. You can see the minus here for the operation, and then you can see that the student put the minus in here and only allowed that minus to affect the positive 3. It did not affect the negative x. That is the incorrect way to work that problem. So here again is the parentheses like I've been using. Here's the minus operation sign, parentheses around that numerator, and then you see the 2 sign changes down here after we remove the parentheses. All right, so let's try the more difficult ones where the denominator does not match. What's the process that you're going to use there? You're going to take each denominator and factor it. The first one's prime. Second one's the difference of 2 squares, and it factors x plus 5 and x minus 5. And in determining your LCD, if you have a factor that occurs once in one denominator and once in another denominator, you list it once in the LCD, and then you have to account for this other factor of x plus 5. So your LCD is x plus 5 times x minus 5. So let's see about working this. Let me see if I can keep all that on screen. And when I write down this first fraction, I'm going to make the fraction bar a little longer than necessary because I'm going to come back and do something in just a minute. I'm going to go ahead and write this denominator down in factored form. Here's the difference of 2 squares. We're going to break it down into x plus 5 times x minus 5. And this is where we do the comparison step. So I want you to look back up here at the lowest common denominator. It has a factor of x plus 5 and a factor of x minus 5. I'm comparing what's in this first fraction to what I want up here in the LCD. And I see that I am missing, notice me putting parentheses around all of that, I'm missing the x plus 5. So I insert that in the numerator and the denominator so that in essence I'm multiplying by 1. I'm not changing the value, I'm just changing the way it looks. So that's my first step, comparing. And now I'm going to go to my second fraction. I'm going to compare that to what I want. I see that I already have everything, so I'm going to leave the second fraction alone. And this is where we go to the single bar, because now the denominators do match. So you write that common denominator down once. I think I'll go ahead and put this extra step in here and come back on the next line and actually multiply these two binomials together. All right, so we're going to do first times first is x squared. Outside product is 5x. Inside product, excuse me, is 5x. And the last product is 25. And I'm going to do a little combining up here, so I see an x squared, no matching like term. Here's a plus 10x. And then here's a 25 and a minus 1, excuse me, a minus 100 or negative 100. So I'm finished with the actual subtracting here. I see I made a sign error right there when I was coughing. So you're done with the actual subtracting when you get there. The last thing you want to check on is to see if you could possibly reduce this down. And I'm noticing, I think, let me try this, that this numerator, I think if I use a positive 15 and a negative 5, I believe that will do. Let me look. Does that give me a negative 75 on the end? Yes. And does it give me a positive 10x when I combine the inner and outer products? And it looks like it does. So I see I can do a little cancellation here to reduce this down to lowest terms. So let me change my color and cancel out these x minus 5s. Notice again you can cancel because they are factors or they are multipliers. And it looks like we're going to end up with an x plus 15 on top and an x plus 5. And do not be tempted to do any more cancellation because these are all connected with addition.